This is Del Volink, and this is Vanessa. Say hi, Vanessa.
Hi.
Vanessa is such an amazing student and such a sweet person for helping me out with this.
Thank you.
We're going to work on, Vanessa's here from Vietnam. This is year 2 that you've been here.
Yes.
And from last year to this year, your English has increased a lot.
Thank you.
Yes, I've noticed that. And Vanessa might be taking ACT again, and we had a little discussion about the dreaded word problem. For Vanessa, it's not so much a problem with the math, it's the language and the English that gets in the way. So what I'm going to do is I'm going to work with her a little bit, kind of a tutoring one-on-one session, because I don't have a classroom to teach this year. We're going to do some tutoring, and I'm going to show her some words that will help out with understanding more of the English part of the ACT type stuff. All right, so Vanessa, how is your verbal, you think, if I were to read a problem to you? Is that easier or harder than if you read the words? What do you think?
I think when you read it, it will be easier.
Okay, so I'm going to try one out. You ready?
Okay.
See how your math is in your head.
Okay.
What is the total cost of 2.5 pounds of bananas at 34 cents per pound and 2.5 pounds of tomatoes at 66 cents per pound? So you might not know what the number answer, but do you know what to do with the numbers?
Yes, I guess.
No looking. You wanted to hear it.
Okay, I cannot remember the
the numbers?
yes, the
okay,
numbers.
So there's 2.5 pounds of bananas at 34 cents.
Okay.
And 2.5 pounds of tomatoes that are
Okay.
66 cents. What would you do? What do you do with those numbers?
Wait, what's the question?
What is the total cost?
Okay, I'm gonna times the. Okay, so
I'll let you
like
look at it.
I need the price of the bananas.
Okay.
So like I'm gonna times 2.5 pounds times 34 cent.
That's right.
34 cent, and like the price of tomatoes, I will times 2.5 pounds times 66 cents, and then sum them up.
Very good. Now, how do you know to add them together? What
Because,
told you that?
Is the total cost.
Good. Total. Total is one of those words that would be like you're going to have to do something, do some adding. Good.
Okay.
And how did you know that you had to multiply pounds times the money?
Okay, because like 1 pound is 34 cents, so 2.5 pounds is 2.5 times 34 cents.
Makes sense. Good. So you're okay with the word total. You're okay with
Okay.
something like that. All right. Let's do a little more algebra.
Okay.
And there's a word in here that's interesting. And we're going to read it together.
Okay.
When x equals 3 and y equals 5,
Yes.
by how much does the value of 3x squared minus 2y exceed the value of 2x squared minus 3y?
Well, I think I'm gonna get trouble in this one because I don't know the word exceed means.
Exceed. Okay. This is a really cool word. So remember we talked about a little bit, we're talking about words that tell you to do what operation? So you know to add, subtract, multiply, divide, right?
Yeah.
If I get a speeding ticket,
Okay.
I'm exceeding the speed limit.
Okay.
So I'm going over it. I'm doing more than the speed limit.
Okay.
My salary, because I'm a bazillionaire, my salary exceeds every salary in this building.
Oh, okay.
What do you think?
So it's increasing.
Increasing more than.
Okay.
Okay, so when you have how much does this value exceed the other value, how much more is this one than that one?
Okay.
Okay, I'm going to give you a marker, a pen. There's some algebra there if you want to substitute and do those.
Okay.
I'm going to turn the volume off of my phone because that is my life. Someone's going to call when I'm recording. So I'm turning it off. That's what happens. Okay, I'll let you do a little bit of math there.
Okay, do I need to talk?
You don't have to talk. No, no, it's okay. We'll just all stare at you. Vanessa's substituting all the values in for the expressions, and she's calculating.
Oh no. I did something wrong.
Well,
okay, it's 9 times
9,
2
18.
18 minus 15
It's
is
3.
Yeah.
It's this one you made a mistake.
27 minus 10.
Minus 10.
Is 17.
Yes. Okay, so this is the first one and this is the second one, right?
Yes.
How much does this exceed this one?
So it's 17 minus 3 is 14.
Correct. So
Yeah.
the first one exceeds the second one by 3, or by 14.
Okay,
By
so
14.
it's B, 14.
It would be B. Correct.
Okay.
All right.
Okay.
All right. Now I'm going to do what I used to do when I teach in class. I always tell my kids, ACT, AP test, SAT, you can't work in a group.
Oh, yes.
You know,
that's
because a
right.
lot of math teachers are like, okay, go work in a group and ask your friends. When you go to the ACT, you can't ask your
Yes.
friends, right?
You
Okay,
will be
so
dismissed.
I'm going to be really, really mean,
Okay.
and I'm going to make you do
Oh,
number 10,
It's the longest.
number
freaking one.
7. Hey, the size doesn't matter, okay? It doesn't matter. That means nothing. It might look scary. It's really not that scary.
Okay.
Okay, so the green circled ones,
Okay.
I'm gonna give you, you know, some time to look at them and pretend, you know, you're on your own. You can't phone a friend. You can't
Okay.
go on the internet.
Okay.
And so you're gonna try those 3 by yourself as if you were taking the test.
Okay.
And I'm gonna wheel away for a second.
Okay.
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 All right. Good. All right. So I peeked a little bit while you were working. If a negative number is subtracted from a positive number, which of the following will always be the result? And you picked a positive number. How'd you figure that out?
Because like the negative number, like in ACT, like I never like use the concept to solve the problem. I just like pick the random number.
Pick examples.
Yeah, pick example. It's like -2, like 3 minus -2 is like 3 plus 2, so it's always positive.
That's right. Whenever you subtract a negative number,
It will
subtracting a
always
negative.
positive.
This is the only time in life that
Yeah.
2 negatives make a positive.
That's
Okay. Good. If x and y are both positive integers, do you know what an integer is, or did you just guess?
Yes.
Oh, nice. Okay. How would you explain an integer?
Oh, that's hard.
Okay. Why is that hard to explain it?
Okay, integer.
You must have known what it was because you did answer it correctly.
Oh, I didn't answer it correctly.
You did.
Oh,
So you must have an idea of what integer is because you answered it correctly.
it's a number.
Okay.
It can be positive, it can be negative, but it's like it can be written in the like the number form.
Okay, how about this? Give me an example of an integer and an example of a not integer so I can just see what you're talking
Okay,
about.
2 is the integer.
Uh-huh.
2.5 is not in. Oh no. Yes, 2.5 not integer.
2.5 is not an integer. Okay. What about an easier way of explaining integer? If you know that 2 is and 2.5 isn't. What's another way to explain integer?
Like they have a dot.
Oh, interesting. Okay.
Yes.
Okay. What's the word for that dot in English? Do you know what that is?
Period. No, it's not.
Not in mathematics. I mean, it's the
Oh.
same symbol.
Diminal.
I'm going to write it.
Yes, these. Okay.
Decimal.
Decimal.
And deci because of the Latin for 10.
Okay.
This breaks it up into
Decimal.
smaller
Yes.
tenths. Yeah, decimal.
Decimal.
So it is the same thing as a period when you type it. Yeah.
Yes.
We call it decimal. So this is not an integer,
Yes,
but this is.
that's right.
Okay, so integers are not decimals. They are whole numbers. That's what we call them.
Yes.
Whole numbers. So they don't have anything left over.
Yes.
Whole number.
Okay.
Good. All right, so we got exceed today. We talked about integer. That's awesome. All right, so what was going on with number 10? I don't think you liked that one.
I don't like that one.
All right, so I'm going to read the words just so they can hear what you're facing here.
That's right.
In the standard xy coordinate plane, the triangle with vertices at 0, 0, 0k, and 2m, where m is a constant, changes shape as k changes. What happens to the triangle's area expressed in square coordinate units as k increases starting from 2? So for those of you that have already fallen asleep, sorry, but this is the question that Vanessa's dealing with right now. All right, so I see you made some little squiggles here. Okay. So standard xy coordinate. I see you made this.
Yes.
Good. This standard xy coordinate is the xy coordinate for my people in the audience just wondering. Yes, that's the standard coordinate that you were graphing on since probably 8th grade. Okay. 0, 0. Where's 0, 0?
Is origin.
Origin. Very good. Origin. So 0, 0 is origin. 0k. Where's 0k?
0k is like k is on the x-axis, Oh no, y-axis. Oh no. Yes. Okay. So k is on the y-axis.
Okay, why did you change your mind there? I'm just curious.
Because I just drew k on
That's
the
fine.
axis.
Okay, but
Yes.
you knew.
Yes, 0 and k, like the second one, the second unit always like stands for y value.
Very good.
So-
Excellent. So it's we're gonna go on the y. So we're gonna just put k on the y-axis.
Yes.
Whatever, however far k is, we don't know. K is anything, right?
Okay.
And 2m. Where's 2m? How do you get to 2m?
2 is on the y-axis. X-axis.
X-axis. Good.
Yes, so 2 and like m is on the y-axis.
Mhm.
Yes, so like somewhere.
Somewhere, but
Yes.
not over here.
Yes, like 2 over there and like m is
So what quadrant would it be in? Ooh.
1.
Nice. You know the quadrants. Good job. So it would be in quadrant 1 somewhere.
Yes.
So 2m. We're going to go over 2 and up m. So we know this is 2 and this is m.
Yeah.
And this is k height.
Yes.
Agreed? Okay. M is a constant. What does that mean, m is a constant?
No change.
Okay. And where m is constant, changes shape as k changes. So what's happening with this triangle? M is constant.
Yep.
What happens as k changes?
The k will like lower or higher.
Good.
Yes. So
K will go up or down.
Yes.
Can k go left or right?
no,
Why?
because it's 0k. So
Very good.
Yes.
So it has to, it's just gonna, k is gonna do something up and down. Okay, and it's gonna affect the triangle. Where's the triangle?
There.
Excellent. Okay, so as k goes up, what do you think's gonna happen to the area of the triangle?
Increases.
It's gonna increase. Okay, and as k goes down towards 0, what do you think's gonna happen?
It will what is it?
What's opposite of increase?
Decreases.
Very good. Decreases. All right. What happens to the triangle's area expressed in square coordinate units as k increasing?
This one is base and this one is height.
You can. Very nice.
Okay, so this one is k
All right.
and this one is 2.
Nice.
Oh, yeah.
Oh, woo! Hold on, let me get the light bulb. You gonna put the light bulb in your head? Okay, good. So you figured out that you should look at it like this.
Yes.
So this is gonna always remain 2
Yes.
for the height. What's changing?
K.
Okay, that's the base.
Yes.
Okay, so the area of this triangle will be 1/2 base k times 2.
Yes.
What's a half times 2?
1.
So the area is k.
Yes.
Right? All right, now k, this is going to increase now. K is going to get bigger and bigger and bigger.
Yes. So
What happens?
Area is increasing if k is increasing.
I agree. I think you know these words. Ooh. Number 14.
Okay.
And I'm going to take the other sheet with me so I can find more challenging words.
Okay.
Okay, try 14.
Expressions.
Did I pick a good one?
Yes. That sums it.
All right, I'll scoot back. Do you think you're going to, is it the words you think? What expression? What's an expression? In math.
The expression.
Expression.
I know what it means, but I don't know the definition.
Okay. This, 2x plus 3, this is an expression.
Yes.
Okay, this is not an expression.
Yes.
What's the difference?
It has equal.
So equations. Expressions are just representations of things that aren't equal to anything. Expression. So x is an expression.
Yes.
Okay, so those are expressions. So you have to find an expression. Must the center cell of the table below contain, what does that mean?
Include.
Has to be in there, good. So that the sums, there's that word sums, very British, sums. Let's
Yes.
just do our sums. What's our sums?
Add them together.
Add them together, very good. So we have exceed, and sums would be another word that we did.
Yes.
So that the sums of each row, which ones are rows?
Row is the horizontal one.
Yes, good, horizontal. And each column. Okay, so that the sums of each row, column and diagonal, what's a diagonal?
This one.
Good. Are equivalent. Ooh, equivalent.
Equal.
Equal. Okay. So let's look at the first row. If we were to add these things together, x plus 8x plus a negative 3x, what's that going to get you?
6x.
Okay. So we say that's 6x. 7x
Minus 4 is 3x.
plus a 3x.
Oh, okay. So it's 6x.
Okay. So the bottom row is 6x. Let's do this column.
Okay.
X minus 2x, negative 1 plus 7.
is 6x.
So this way it's 6x. Let's do this one. Negative 3.
6x.
It's going to be, okay, so you've got an 8. What do you think this has to sum up to? Like, how much does this have to equal?
Is 8 plus negative 4 is 4. So 4x equals 6x. No, wait.
Well, you want the
4x plus
how much to
how
make
much?
6x?
Yes.
So 4x plus how much to make 6x?
So it's 2x.
That's right.
Okay.
Good?
Yep.
Yay! All right. All right. Got a couple quick things for you. We're going to have more fun. Just words I thought we could work on. We saw exceed and sum and product, you said. So we have a few of them here. If I verbally said this, could you write an expression for me? Okay. 9 less.
Wow.
Oh,
Okay.
okay. 9 less than the total
Okay.
of a number and 2.
Of a number?
Of a number, any number, so that would be your variable. 9 less than the total of a number and 2.
Of the number and 2? Okay.
9 less. Very good. Awesome. All right. So what Vanessa came up with, I saw her, she changed her mind a few times. So and most kids do this. If you start a problem with the number and you say 9 less, they always write the number
Yeah,
first.
that's
And they go,
right.
oh,
They
because
will write
you
9
want to put
minus
it in the
this.
back. Yeah. So 9 less, and then she did a sum of x plus 2. Awesome. Okay. Another one. The ratio of 9 more than x to 3. The ratio of 9 more than x to 3.
2, 3?
To 3. And I'm going to say, instead of saying 2, 3, I'm saying to 3. Like, the ratio
Like
of...
23?
Like
No,
what?
it's not.
You want to read it, don't you?
Oh, I really want to.
Okay.
Okay, 9. The ratio?
Of 9 more,
9 more. Okay.
then take a look at the end here. 9 more than x to 3. The ratio of 9 more than x to 3. I'm trying to help you with the way I say it. Yay! Okay, but think about that. Like if someone were to say that, even native English speakers, ratio of 9 more than x to 3, you might hear 2, 3, like
3,
the number
yes.
2. Yeah, like that's kind of confusing. And then a ratio of 9 more than x, you got to know that those go together.
Okay.
Good
yes.
job. All right. The average of the weights of 3 children is 80 pounds. How would you express that using like a variable?
Wait, can you say it?
Mhm. The average
Okay.
of the weights of 3 children is 80 pounds.
The average of 3 children.
The average of the weight. And let's assume the kids don't weigh the same.
Is 80?
80 pounds. Nice job. All right, you add x, y, and z. Good, because you can't just do 3x. That would be if they all weighed the same.
Yes.
Good job. Okay, one more. James has twice the number of apples as Kristen, but 1/3 the number of apples.
Wait, can you say it again?
James has twice the number of apples as Kristen, but 1/3 the number of apples.
But 1/3?
But 1/3 the number of apples. So James has twice the number of apples as Kristen, but 1/3 the number of apples.
I don't understand the part, but 1/3.
Okay. So we got the James has twice as much as Kristen. Like you're okay with that?
Okay.
He has twice as much. So what does that mean if I have twice as much than you? How would you represent that?
It's like 2x.
2x. Okay. So James is the same as 2 Kristens.
Yes.
Okay, you agree with me there?
Yes.
Yes. Okay, good. You have that. but 1/3 the number of apples. We don't know the number of apples, so that would be another variable in this case. So 1/3 apples, not
so
not
except
necessarily
for
because this is Kristen.
Okay.
Yeah, you're saying James has too much as Kristen.
Yes.
We don't know how many apples. That was a tricky
Okay.
one.
Okay.
Good job. I'm impressed. All right, I think we're gonna stop recording for today just to show this is what we'd be doing.
Okay. Yes.
Okay, did any of the words help?
Yes, I know.
We did exceed.
Yes.
Exceed was a new one for you. I showed you decimal, but you knew decimal.
Yes.
You just didn't know how to say it.
Yes, it's like I remember it's like D something.
That's awesome that you remember.
Is it decimal?
Decimal. is what we say
Decimal.
it. Yep,
Okay.
decimal.
Decimal.
Mhm.
Okay, thank you.
Yeah, awesome. Well, thank you for your time today.